Hey everybody, this is Larry, this is Miko with Q4 of the weekly contest 49, maximum subarray XOR with bounded range. Yeah, that was a mouthful. But hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Yeah, and I think this is pretty tricky, but I think there are some ideas to play around with. Let me pull up the drawing board real quick. How do I set this up? Right. Sorry, I'm a little bit slower because I hurt my shoulder a little bit, my left shoulder, so my mobility is a little bit painful. But in any case, yeah, I think for problems like this, it's important to break, for Q4 especially, Q4s in general, as they get harder and harder, more difficult, is that you have to break them into multiple components, right? For me, yeah, so let's just say we have a regular array, and then the idea with these subarray problems is that I think about contribution, right? Meaning that, okay, if this element is the last element in, like if you want to solve the problem for the left side, then how would you solve it as a subproblem, or as not a subproblem, the other problem, as an incremental thing from the other one, right? Okay, so the first thing, and this is where also sliding window comes in, right? I mean, yeah, okay, you're trying to solve for here, but you know that maybe the best answer is going to be only here or something, right? And then now when you add this box, maybe you only consider these things, right? And this particular left line will never go back to the left because, or you effectively eliminate all possible answers from the left. That's kind of the idea. And then for this particular problem, you have this like difference between max and minimum thing, which I think was I don't know. I feel like it was on a contest very recently. It's the same idea, so I was able to implement this. Or I didn't implement it yet, but I had the idea in my head very quickly, which is that of course this is a sliding window, kind of what we hint at. Let me change the colors. What we hint at before of the sliding window, because the thing is that if you add to the window, it will only make the gap bigger, and if you subtract from the window, it will only make the gap smaller, monotonically smaller. Well, not monoton. What's the word? Not strictly smaller, but strictly. So it could be equal to, but that's why you get this sliding window effect, right? And then, so that's the first part when I looked at the problem, and I go, okay, so now let's say so then I reduce this problem because we know how to solve we know that the answer is going to come from a sliding window. Then now we reduce the problem such that, okay, let's say we have this window, right? And then we just add this element. How do we, and let's just say we pop things off, right? So then now this is the window. How do we get the answer? And that's kind of the way that I spent the second time. And then eventually, honestly, it took a little bit of time. I just came up with the prefix XOR sum in this case of this idea, right? And we call that for prefix sum, and this is critical, right? Is that, let's say you have some prefix sum that goes up to this element. And then the idea of find the maximum, it's going to be this prefix sum minus some prefix of the prefix sum, and then if you kind of subtract these and it cancels out, then you get this, right? So then now it means that given this prefix number, this number here, we're trying to find a number here that maximizes this these delta, right? And it turns out in XOR sum, of course, you can figure that out because then now you can look at it all at once by looking at the prefix sum at this interval, this interval, this interval, and this interval, and this interval, all at the same time. Of course, in a naive way, you can do, with a for loop, but that's going to be O of n. So you're trying to figure out a way that is faster than O of n. And it turns out that because it's an XOR, you could use a try, right? Why a try? Well, a try or a prefix tree, in this case, we'll just have 0 and 1s, right? So it's a binary try, and then the idea, and this is a circle node, not a 0 or 1, just to be clear, right? Because the 0 and the 1 are on the edges, right? So maybe 0, 1, 0, 1. And then the idea here is that, okay, well, if we're on this prefix sum, and you have some number, let's just say 101 in binary, then what happens, right? That means that, well, we're trying to look for inside here, 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 and here. To get the maximum, it's going to be this number minus this prefix, right? So this can go to here. And when I say we check the number here, it means that we check the prefix of this prefix, this prefix, this prefix, which in turn, the subtraction will give you this interval in between, right? And because we're trying to maximize the interval in between, we just check it one at a time. So it means that 101 minus some interval in between, let's just say k, is equal, and we want to maximize this number, right? So we want to max this number. I'm trying to find max here, but we kind of went out of space. So we're trying to max this number, and of course we max this number by, well, just asking yourself in a brute force way. Hopefully you got everything on top, so then now I could remove it. So you have a formula in which you have 101 minus some k, and just, I mean, there are more digits, but we'll go with this for now. And we're trying to maximize this, right? And we can maximize this by one at a time. We look at one, right? And we do it in a greedy way by the most significant digits first. So here we see that there's a 1. So we just ask ourselves, well, is there a 0? Because if there's a 0 in the prefix, then 101 minus k is going to be 1, right? And of course, in this case, I say minus, but minus in XOR is actually XOR, right? So maybe another way to write this is that, well, 101 XOR k, we're going to maximize this. So we're going to try to find 0, right? If it exists, then we have 1 as the result. If it doesn't exist, then and keeping in mind that because the way that you do it, you can always find an element, right? So do not create an element. But if this is if the 0 path does not exist and you have a 1 path, then 1 XOR 1 is going to be equal to 0. And that's the best you can do because you have no choice. But if there is a 0, then 1 is the best you can do, right? And then you kind of do a digit at a time, and that's how you use the prefix try. And that's basically it. I mean, I had a XOR try rather, but in a prefix kind of way. And I kind of made some mistakes that took a long time because I kind of confused this problem a little bit because I was just going too fast, kind of. I confused this problem where you match up a number with a previous number and not a prefix number with another prefix number, right? So it's a very subtle thing, and if you watch the live portion, you'll see where I made that mistake. But that's it. Okay, so first of all, we have a try. We have a sorted list for the window. We have two things for the try. We have add and remove, and these things are pretty standard. So I'm not going to go over in detail, right? For the try, it's just that, yeah, you add a number and you go for the most significant digit first, right? For remove, you just we just keep a count at each node to count the number of elements in that subtree. And add is the same thing except for an opposite, if you will. The only thing addition is that you have to create a node that doesn't exist, right? Okay, so these are the add and remove to the try, and then you have the sliding window that as you kind of add more elements, you just we'll go over it real quick. And of course we do the prefix something, which I'm not going to go over for now, but we'll go over in a second. But yeah, just focusing on the sliding window for a second. This is the sliding window component, right? You have the left the left side of the window, the right side of the window, you add stuff. And then while the invariant unholds, because after this, that means that the invariant is that every element in the window is within K or something, right? But of course, then you also have to update and remove the prefix tree. And that's basically the idea, is that, yeah, as you kind of remove elements, then we remove the consideration of the prefix. As we add elements, we add the consideration of the prefix. And then now, this is the greedy idea that we talked about, right? So here, yeah, for each. So we set the current is equal to root, and we want to check the prefix the current prefix, right? So we have two things for the prefix. One is the current prefix, and one is just the prefix array. You could probably do it without the current prefix by just using every one of the prefix array. But I just find it a little bit less confusing and easier to type. Yeah, because this is current prefix just contains all the prefix up to this current number, and then you append it to the prefix anyway, the prefix tree. Yeah, and then when you update try, or when you update the window more specifically, you remove the previous prefix sum away from the thing because you're no longer considering that as part of the thing, right? Because you can't, because it's just not within the gap window, right? But yeah, basically this is trying to match greediest with the result. So this is what we get for the result. If we have a 1 in the current bit and there's a 0, then we get 1 bit, right, in the final answer, because it's 1 XOR 0, we get 1. Otherwise, we just take the 1 and then we keep going. If the current prefix bit is a 1, if it's a 0, then we see if the 1 exists. If 1 exists, then we get a 0 XOR 1, which is a 1. Otherwise, we go back to 0. And that's it, right? That's basically make it small so you could see all of it, or more of it rather. This is the try node. Add and remove on the try. And this is okay. Well, this is the beginning of the sliding window with the prefix sum, and yeah, and this is the critical part of the greedy on the current prefix. And then we just kind of update the best and add it here. And also keep in mind that I added it over there for some reason. You can also add it here. It doesn't matter because it would otherwise match everything to 0, so it doesn't change the result. As in, like, it would match itself with itself, which the answer is 0 because that's the XOR, right? Maybe that's a little bit cleaner. And let me not lie to you by submitting it first. Well, I guess that's not first, but submitting it in that case. Yes, it looks good. But yeah, and that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you can watch me solve it live during the contest now. But it works without, I don't know. So I still have to change to Java. Maybe there's a cleaner solution, but I don't know. Alright, thanks, Leetcode. Alright. Let's do Q4. Maximum subarray XOR with bounded range. Okay. Non-negative integer nums and an integer k, subarray of nums such that the difference between max and minimum element is at most k. Okay. Okay. The value of the subarray is the bitwise XOR. Okay. Is it sliding window? I mean, sliding window will give you possible windows, but it will not maximize the XOR, right? So we can select all the subarrays. Then it is about so you have a subarray and then all the subarrays that are inside that subarray. So you have the longest subarray, and then you want to XOR either some subset of that, right? Okay, it's 15 maybe. I mean, I actually wasn't going to think about it, but 2 to the 15 is such an interesting number. Maybe we could do something with bits. So, okay, so let's say we have a sliding window, right? We have the window, and then now we're trying to figure out it's an XOR, right? XORs are tough. I mean, we could do it. So can we query max bits, right? That's interesting, actually, an observation. It's always at least one of the numbers. and we do it a bit at a time. So we maximize for the maximum bit. It's a prefix thing. Now you can't do it for every sliding window though, can you? Okay, so given a sliding window. Oh, well, okay. Well, with a sliding window is that this number is the last number. So then you can go back. I forgot about that. Okay, that's fine, maybe. Right? So then, okay. Okay, so then you ask yourself, is there so you want to optimize a 1, which is the even number of things. But you don't always want to greedy go the farthest for the maximum value. That's the hard part. Is there a way to binary search? Because the thing is that this is not the XOR is not continuous enough to be binary search. So then okay, so you add this number. So let's say you have a no, but then you want to add it goes left and right, right? Is there a DP that's based on this? To starting window for what? I don't think there's anything other way to do it. So you add a new number, and then okay, so this number, can you solve in O of log n time? What is the maximum possible value? Do you put it in like a dynamic try or something? Like, can you? I guess so, maybe. An XOR try or whatever. Okay, I think that makes sense. Let's. Yeah, I mean, okay, I think that makes sense. How do I want to do it? Okay, so let's just sort a list. I'm too lazy to do it the other way. I don't want to think about it, that's all. You could do it with a mono queue. Okay, so for X in nums, if or while I don't need 2 of them. What am I doing? I think I'm confusing with a different problem, but nonetheless. Okay. Well, oops. Right, and now do stuff, right? So we'll, yeah, and then we will update try try, and then yeah, and then insert, right? Yeah, okay, I think that's fine. I think that's the answer. Just have to fill in the rest. Should be okay. Okay, and now we want to try 15 nodes. Is actually kind of weird, but okay. And I'll type here maybe. Okay, check. Okay, we want to remove. Let's do the check first. All right, we want to check by. Okay. Uh, we want to go the direction that gives us 1, right? So then current best is equal to 0, say. So now, yeah, we just do for, let's just say B for whatever. I know B only goes up to 15, but I'm going to do like 18 for sure. Okay, so if then we want to go to 0, right? So and if it doesn't exist, then we just, yeah, it's a little bit weird. Okay, fine. If current dot edges of, so we want to go to 0 no matter what, and we can't go to 0 no matter what. Well, we can't get a 1 no matter what. We'll go that way, right? Is not none, then 0, and then we do get a 1 bit this way. If it is none, we still do it, right? It just means that we have, yeah, we still do it because we have a 1, so we just take the current path. So that means that actually, if it is none, then I mean you could shortcut it, I think, but I'm just gonna write it this way. Why am I doing this? What is the logic exactly? This is not quite right. Okay, so if this is a 1 and the 0 doesn't exist, how does that work? Do I do it that way? No, I don't think so. I think maybe we just set this to the current node, and then if there's no 0, then we just can't go. Is that the better way? Yeah, because you create the rest of the path anyway. But that means that if you take only this number, then you only have this number. So I don't maybe that doesn't make sense. So if it's none, what do we do? Maybe this is fine. Okay, let's see what happens. Okay, if there's a 1, right now, well, yeah, but okay, so now if this is a 0, check if there's a 1. If it's none, then we go to 0. Wait, is that right? No, this is, we try to go to the 1. If this is a none, then right? I mean, you could shortcut this for obvious reasons. It should be fine. But we have to be able to remove, so this isn't quite... I need to do a... I think this one is fine only because we always create one anyway. Maybe? I don't know. Man, I'm like really bad at this. This is stuff that I used to be really good at, but maybe not. You can't use it if it's not there. Otherwise, then you use it. So something like this, and this should have been cleaner, but oh well. We'll see what happens. I have a feeling I'm gonna have to debug this. Okay, now insert. This could have been more dry, but okay, that's fine maybe. Yeah, and then now I have to do the remove. Maybe I should put it in the helper. Like this is very helper friendly. Let's just say. Keep it consistent. Did I do this way? I meant... Huh. That is pretty bad actually. I was thinking about it when I was writing it, but then at some point I forgot. And then like writing this, I was like, wait, did I remember? Huh, maybe not. I might have to, on the add, this might have to, just for consistency. Okay. Okay. I don't think this is quite right, but yeah. 1515 is definitely not right. Let's see. Am I doing this? Okay, so you go to 2 to 5, so it's gonna be the entire array. Which is fair. Here. And the 6, where does it do? Is this right? Am I doing this right? No. I'm just adding this wrong. Huh. No. I'm doing things wrong. Because I'm just matching numbers. That's not what I'm meant to do. I don't meant to pair one other number. It's like should be more like a prefix thing. So I'm doing this wrong. This is not right at all. Huh. How do I want to do it? Prefix sum? Prefix sum makes sense. And then you just, okay. So I guess, okay, it's not that bad. Okay, fine. That's not a hard fix. I mean, stuff may still be wrong, but that part by itself is not a bad thing, right? And this is why you want a modular thing, but okay. I don't know why we used X. Maybe not. Okay, fine. Okay. But then now we just need prefix. Right? Yeah, okay. That's not bad, actually. And then now, and this is technically fine, though it's a little bit awkward. It's not X. Oh, well, when we do want to remove X from the thing, but well, we want to remove this from the thing, but this is not right. So actually, we want maybe something like this. Right, and then now we want to remove prefix of left plus it's a little bit off, I think. This left is not this left. This left is the index left. So it should be left. So left is 0. This is so annoying. Okay, so left is 0. We go, okay, let's remove the 0 element. We want to remove the contribution of, no, I think this is right actually, by accident maybe, but okay, I just want it real quick. Still very wrong. It should not be 16 for some reason, or 15. Well, I didn't fix it yet, that's why, because this should be this should be current prefix now. Yes, that's it. I only need to fix it in one place. Actually, wow. Okay, 14 is still not right, but I don't know. Okay, 5. What's 4? 4 should be, so then that prefix is 1. No, 4. 11 doesn't make sense. Why is it 11? Okay, so basically it's no. That's why for sure. I mean, there might be other issues, but that's definitely an issue. Okay. This one is right. This one should be 4. or 5, I guess. Really. But okay, 5. It goes 1 to itself. No. Oh, 0 doesn't exist. So 0 doesn't exist. Then it tries to do. How do you get 14? Did I do the math wrong? This B is wrong. I mean, it shouldn't matter, but it's off by 1 anyway. Okay. Alright. I mean, this should be 5 and not 4. Something is still wrong on this thing. Why my XOR tree so bad? Okay, so this is definitely a 1 on the 4-bit. So edges of 0, no, I don't know, but so then it inserts in the 4-bit, right? And then now it goes 0, so it wants a 1. There's no 1 on the side 2-bit, so it does this. And then now there's a 0 and a 1. It is a 1, so it looks at 0, right? No, that doesn't exist because we created a new one, right? So yeah, so it should go here as well. Why? Is this not 5? Why is this 4? It's a 1, so it looks for 0. Okay, I guess we just have to do it. I don't know. Don't know how to read this exercise. 5, 1, and 4. It goes 5 on the 2. There's a 0 path, that's true, but there should be a second one. So I went here maybe, and then it does it again, right? Why not? Yeah, why is this not? Did I set my things wrong? Oh, this is X, but we want current prefix. Maybe I got confused. And current prefix may be weird, because we're trying to match. So the current prefix is 4 because it's 545, I see. And then now, do we add the right prefix? It should be, right? Because we want Subarray. Yeah, no, I mean, we have half an hour. We should be able to figure this out. Okay, so this is 4 because that's why. Because I've been debugging the wrong thing. So the prefix is 4. What does 4 mean? 4 means that we want to. This prefix is 4, and this is the prefix we want to subtract, which is 1. Did I do this wrong? Am I thinking incorrectly? We want to optimize the prefix to subtract from, right? Which is the same as for an XOR. So we have a prefix of 4. That means that we want to subtract a 0, right? 0, 0, and then 1. We go down the 0 path, and then 4 should be 0, right? Yeah, 4, 0 should be here. Check if there's a 1, right? And there should be a 1. Oh no, this is check if there's a 1. There should be a 1, and we didn't remove anything, so something like that. Yeah, no, it should be here. And maybe it goes this way. No. This is the double negative is kind of bad, actually. Okay, so maybe it goes this way anyway, though. But we added 5. So, and if we added 5, then okay, let's make sure that we did add 5. Not very good today. Adding 0, that's fine. Adding 0, adding 5, okay, so we're adding 0. Adding 0, why did we add 0 twice? Oh, I see. That's where this is y plus 1 because that's just my current prefix. Though I guess we could add it earlier because it just literally doesn't change a thing. But okay. Okay, now it's 7. Oh, that's actually right? And 6. Okay, so that was it. Me being dumb. Why did I change that? I thought there was 1 more point, or maybe 2 more point at least. And add. Okay, 7, 6 looks okay. Before I do, let's do. Let's see. 5 is going to be 5. 4 prefix is 5. 5 prefix is 5. Okay, 7. That's right. Let's look at it for k is equal to 1. K is equal to 1. Okay. I mean, I don't know. Should be more right than before, but not confident. Today's been a rough day for a contest in general. So yeah, not very confident. K is equal to 0. Do I not remove things? Clearly, I even have okay, add 3. Okay, adding 7 as a prefix sum is fine, but not as a best. Why is there a second 3? Did I mess up X? Huh? Well, I mean, that would be Y, maybe. Oh, yeah. I was wondering, that's why I was like, did I do something weird? Why do I have... And then this thing happens. Which I don't think we need anymore, honestly. So that kind of messed me up. But I also think I have X somewhere. Do I? I don't know if I do. But... yeah, okay. Well, I mean, that X might not mean anything, honestly. But, but it's still... add 3, 7, okay. Just want to make sure. So we add 0, 3. We remove 0, but we should also remove 3. So that's the... no, should we? No, that's the one element case. So why is it 7? So we try to add 7, or we try to do a prefix thing on 7. So it's a 1 on the 4. That's fine. We match the 4. And then it's I think this logic is wrong because before I was assuming that we took the X, but actually now maybe it doesn't make sense. Okay, so what does make sense? So you have 7. Okay, goes. Now this includes the 1 element. So that means that it has to be in there, right? So maybe it's only if current dot count. I don't know actually. Because I was thinking, because initially I didn't have the current prefix thing in there, so I think that's why that I wouldn't say it made a lot of sense, but it made more sense when I converted to prefix. So what is going on? Wow, I am just not getting things right. Okay, output 4. That is just wild. Definitely this one. I mean, the fact that this looks asymmetric is very weird. So, okay, so we have 1 in the prefix. We're trying to figure out anything, right? I think it just early terminates or something. Because you cannot get 0, and you cannot just keep it by itself because it is a prefix. So you have to go the path that you're given. Right, and that means that you don't always get to go to 0. Okay, because there's a no 1 element, you just have to go the way that you go, right? So if it's none, I don't know, something like I mean, this may actually not assert correctly because of how we traverse. I think this probably makes sense. Oops. Yeah, I think this should be true. It's just that because we're actually always matching with something, right? So then now, match it. Something like this, right? And if you go to 1, then yeah, if it's different, we do this. I think maybe we do the same thing here, maybe. Okay, if there's a 1, then that's the delta, right? Otherwise, because the asymmetry doesn't make sense in the context. Before maybe you could say it makes sense, but yeah. Why would that be the case? Oh, I see. Because once this stops being true, the rest of it, you just go through wherever you can go, right? So this is not C. No, that doesn't make sense either, because if this is none, then we go here, which means that we assume it exists, right? All right, why? What is going on here? What is wrong? All right, let's add that, remove again. We have 21 minutes. The idea I think is right, but my implementation is bad, so I don't know. It is what it is. So add 0. Okay, we have 0. And then now we check for the 5. Do we not add 0 correctly though? Why? This should. We just add 15 of these. So yeah, I mean, I don't get it. Let's see. Adding 0, 5, 17. We already have stuff, right? I don't get it. Oh, I'm dumb. This is OR. Ah, man, okay. So that would always be, yeah, okay, dummy. Okay, the print statement. Is a statement on, oh no, I had to remove it already. Okay, 765, okay, so now this looks more right. I am a Dumbo. Now let's remove the print. Come on, baby. Okay. I mean, the idea was right. I just was really bad at implementation. Also, I just got confused about the prefix sum. I was adding the number. So I was thinking of another variation on this problem, which was what led me to that way where you greedily pair two numbers up. And I think I definitely confused that one because when you pair two numbers up, then, you know, you would do the way that I was doing in a greedy way. But instead what I wanted a prefix, and once I converted to a prefix, I didn't really convert stuff correctly. And the element that's in the list is always at least it's actually the 0th. It's the no element, so that's like the no point, and so you have to always go through one because then now the invariant is such that you always have one element in the try representing the no set on the no prefix. Okay, and then I just had to follow through a little bit, but definitely was not smart about it. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.